Hello everyone. Welcome to the class of Advanced Calculus and Numerical Methods 18 MAT 21. Today we will be discussing a topic in Module 5, and the topic that I'm going to discuss is Lagrange's interpolation and inverse interpolation under Module 5 Numerical Methods. Myself, Dr. Madhura, Assistant Professor, Department of Mathematics, Sai Vidya Institute of Technology, Bengaluru. Now let us see formula for Lagrange's formula for interpolation and inverse interpolation. So first we will discuss the formula for Lagrange's formula for unequal intervals. When we have a set of values of x and y, which is unknown values, for the unknown function y is equal to f of x, and we have unequal intervals of x, means x values are at not equidistant, then Lagrange's formula is applicable. So let us see Lagrange's formula for unequal intervals. The formula is given by y equal to f of x, which is equal to x minus x1, x minus x2, etc. up to x minus xn, the whole divided by x naught minus x1, x naught minus x2, etc. up to x naught minus xn, and as a multiplier we consider y naught, plus second term x minus x naught, x minus x2, etc. up to x minus xn, the whole divided by x1 minus x naught, x1 minus x2, etc. up to x1 minus xn, and as a multiplier y1, plus third term with respect to y2, etc. Last term will be x minus x naught, x minus x1, etc. up to x minus xn minus 1, the whole divided by xn minus x naught, xn minus x1, etc. up to xn minus 1, multiplier yn. Let me tell you the easiest way of remembering this formula. Observe that a set of values given would be from x naught to xn, means x naught, x1, x2, etc. up to xn. Similarly, the respective values of y would be y naught, y1, y2, etc. up to yn. So in the first term, for numerator, we have to skip x naught. So each of the expressions should be subtracted from x. So we have x minus x1, x minus x2, etc. up to x minus xn. So observe that x naught is skipped in the numerator, and hence the denominator should be multiplied, or denominator should be used subtracting from x naught. So x naught minus x1, x naught minus x2, x naught minus xn. And since you have skipped x naught here, the multiplier should be y naught. Similarly, for the second term, in the numerator, we have to skip x1, and each of the denominator should be subtracted from x1. Multiplier should be y1. Same manner for the third term, numerator, we observe that x2 is skipped, and denominator should be subtracted each term from x2. So x2 minus x naught, x2 minus x1, etc. x2 minus xn, and hence the multiplier should be y2. Same way for the last term, we are going to skip xn in the numerator. So x naught, x1, x2, etc. up to xn minus 1 would be subtracted in the numerator. Denominator, each of the terms should be subtracted from xn. So xn minus x naught, xn minus xn, etc. xn minus 1. And hence the multiplier should be yn. We cannot simply write down the formula. It's better to memorize the formula in this way. That first term, x naught should be skipped in the numerator. Denominator should be subtracted from x naught. Second term, x1 should be skipped in the numerator, and each of the denominator should be subtracted from x1. Similarly, next term and next term goes on like that up to the last term of x and y. So this is Lagrange's formula for interpolation at unequal intervals. And this formula is applicable when the values of x are at equidistant or may not be at equidistant. Like divided difference formula, even this formula, that is Lagrange formula, is applicable both for equidistant values of x and not equidistant values of x. This is Lagrange's formula. And we have interpolation formula for inverse also. So let us see Lagrange's inverse interpolation formula. This formula is framed very easily, keeping in mind just the values of x and y are reversed in the previous one. So everywhere the values of x and y are reversed. So that is why we have the formula with respect to y first. So y minus y1, y minus y2, etc. up to y minus yn. The whole divided by y0 minus y1, y0 minus y2, etc. up to y0 minus yn. As a multiplier, x0 is used. So in the first term, we have skipped y0 in the numerator. In the second term, we have skipped y1 in the numerator. In the third term, we have skipped y2, etc. Last term, yn should be skipped in the numerator. So the formula is as simple as that. If you could frame it appropriately, not by hearting or anything. So inverse Lagrange formula is very easy to remember if you are able to remember the formula for Lagrange's formula for unequal intervals. Just the role of x and y are interchanged in the inverse interpolation. Now with all these, we will move on to problems on Lagrange's formula for interpolation and inverse interpolation. Now let us see problems. Firstly, use Lagrange's interpolation formula to find y at x is equal to 4 given the following data. So we are given with x and f of x values. F of x is same as saying y. So x values are 0, 2, 3, 6. Observe they are at unequal intervals of x, and the respective values of y are -4, 2, 14, and 158. So very firstly, in the solution, let us assume these values as respectively denoting them by x0, x1, x2, x3. And the respective values of y are y0 equal to -4, y1 equal to 2, y2 equal to 14, and y3 is equal to 158. So with this, we will now write down the Lagrange's interpolation formula. So I have written the formula for Lagrange's interpolation. Observe that we have the data for x0, x1, x2, x3. So the formula will be applicable only for 4 set of values. So since we have 4 set of values given in the data, 4 set of values of x and y given in the data, 4 terms will be written in the formula. So those 4 terms will be written based on skipping each time x0 in the first one, x1 in the second one, x2 in the third one, and x3 in the fourth term. So observe that x0 is skipped in the first term, and each term in the denominator should be subtracted from x0. So the multiplier is y0 here. Similarly, observing the second term, x1 is skipped in the numerator. So denominator should be subtracted from x1, and hence the multiplier is y1. Third term, x2 should be skipped in the numerator. Each of the denominators should be subtracted from x2, hence the multiplier is y2. And the fourth term, numerator, x3 should be skipped, and hence each of the denominators should be subtracted from x3. Multiplier is y3. So since we have 4 sets of data in the given, we have 4 terms in the formula. Now carefully we have to substitute all the known terms. And remember, we have to find y at x is equal to 4. And hence x is equal to 4 is the point of interpolation. So wherever x is there, substitute x is equal to 4 and we obtain y of 4. So therefore, y of 4 is equal to, because x is substituted as 4, we are writing y of 4. So numerator substitution would be 4 minus 2 into 4 minus 3 into 4 minus 6, the whole divided by 4 x naught is 0. So we will be having 0 minus 2 into 0 minus 3 into 0 minus 6. And multiplier y naught will be minus 4. Similarly, for the second term, x1 should be skipped. So we have 4 minus 0 into 4 minus 3 into 4 minus 6. The whole divided by x1 is nothing but 2. So 2 minus 0 into 2 minus 3 into 2 minus 6. Multiplier in this case is y1, which is 2. That is the reason in the previous page we see that we have written these values. What are the respective values of x0, x1, x2, x3 and y0 to y3. So this will now help us to easily substitute the values. Next term, we have a plus in the middle. So x2 should be skipped in the numerator. So 4 minus 0, 4 minus 2 into 4 minus 6. Denominator 3 minus 0 into 3 minus 2 into 3 minus 6. And here the multiplier is 14 because y2 is equal to 14. Last term, x3 should be skipped in the numerator. x3 is nothing but 6. So we have numerator written as 4 minus 0 into 4 minus 2 into 4 minus 3. Denominator 6 minus 0 into 6 minus 3 into 6 minus, this should have been 6 minus 2 before. So you have minus 0, minus 2, minus 3. No, same terms will be reflecting in the denominator. So 6 minus 2 into 6 minus 3. 6 minus 0, 6 minus 2 into 6 minus 3. And hence the multiplier in this case is 158 because y3 is equal to 158. Now using the calculator, each of these terms can be evaluated. So we have y of 4 is equal to, first term is minus 0.4444. I have rounded off each of my values to 4 decimal places. Second term would lead to minus 2. Third term is leading to, these are all calculations, you can do it for yourself, 24.8889. And the last term on simplification is 17.5556. So this approximately is equal to 40.001. We can round it off to the nearest integer, which is y of 4 is equal to 40. 40.0001 is approximately equal to 40 only. So that's the solution for the first one by Lagrange's method. Let us see second problem now. Apply Lagrange's interpolation formula inversely to find root of the equation f of x is equal to 0 given f of 30 is equal to minus 30, f of 34 is equal to minus 13, f of 38 is equal to 3, f of 42 is equal to 18. So this is a formula which we have to apply inversely. So Lagrange's interpolation formula, we need to apply inversely. So inverse Lagrange interpolation formula is applicable here. And it is given that f of x is equal to 0. So these two is going to help us to proceed with the formula writing and all that. So it is given that f of x is equal to 0. So f of x is nothing but y. So it is given y equal to 0. And each of these set of values given are of the form f of x is equal to y. So x values are here within bracket. And we observe they are at equidistant values of x. And y values are here after equals. Respective values of y are after the equals symbol. So let us make a note of them, which is going to help us. So x0 is equal to 30, x1 is equal to 34, x2 is equal to 38, and x3 is equal to 42. And the respective values of y are y0 is equal to minus 30, y1 is equal to minus 13, and y2 is equal to 3. Lastly, y3 is equal to 18. Now let us write down the inverse Lagrange interpolation formula. So inverse Lagrange interpolation formula is given by x is equal to f of y, which is equal to y minus y1, y minus y2, y minus y3, the whole divided by y0 minus y1, y0 minus y2, y0 minus y3. Each of the denominators subtracted from y0 by skipping y0 in the numerator. Hence, the multiplier is x0. Similarly, for the next term, y1 is skipped in the numerator. Hence, each of the denominators subtracted from y1, multiplier is x1. Similarly, the next two terms are written. Observe this. In this data, 4 sets of data are given for us in the given question. So that is the reason we have 4 terms. This entire product is one term. The second entire product is second term, and third term and the fourth term respectively. Now let us substitute all the known values. Remember, it is also given that y is equal to 0. F of x is 0 is same as saying y is equal to 0. So each of the terms, when we are substituting, we substitute y is equal to 0 and proceed further. So we are finding f of 0 is equal to f of 0 is equal to f of 0. Substitution step. So y minus y1. Y is nothing but 0. So 0 minus y1 is minus 13. So we get 13 multiplied by y minus y2. Y is 0. So 0 minus y2 is 3. So minus 3 multiplied by y minus y3. So 0 minus 18 is minus 18. I will add up or multiply the multiplier x0 here. X0 is nothing but 30. The whole divided by denominator y0 minus y1. Y0 is minus 30 minus of minus plus 13. Similarly, minus 30 minus 3. Minus 30 minus 18. So this is the first term for us. Similarly, the next set of terms I'm going to write, it is 30 into minus 3 into minus 18 into 34. The whole divided by denominator minus 13 plus 30. Second term minus 13 minus 3. And the last term minus 13 minus 18. Similarly, third term 30 into 13 into minus 18 into 38. The whole divided by denominator 3 plus 30 multiplied by 3 plus 13. And the next term is 3 minus 18. I have included the multipliers x0, x1, x2 here only because it is also a product along with the numerator. And the last term 30 into 13 into minus 3 into 42. 42 is nothing but x3. The whole divided by 18 plus 30 multiplied by 18 plus 13 multiplied by 18 minus 3. So for each of these terms, we can use a calculator and obtain the values. I have rounded off all my values here to 4 decimal places. So this gives me minus 0.7821 plus 6 second term 5323. Third term on evaluation gives us 33.6818, and the last term is minus 2.2016. Each term I have evaluated separately, rounding off to 4 decimal places, and hence f of 0 or y value at x is equal, sorry, x value at y equal to 0 is f of 0 is approximately equal to 37.2304. 2304. So these are the problems on Lagrange's interpolation formula and inverse Lagrange interpolation formula. Hope you have followed these problems. Thank you for watching.